Have you ever wondered why your malware or phishing pages work perfectly in your environment but fail once delivered to an enterprise target? Well, it's probably because of something known as secure web gateways. But here's the thing, secure web gateways are not so secure and can actually be bypassed. This is Zaid from zSecurity, and in this video I'll teach you all about secure web gateways and modern techniques to bypass them. We're going to use AI to generate undetectable phishing pages. Trust me, your mind will be blown. But stick until the end, as we're going to have the legendary hacker Vivek, who discovered the famous cafe latte attack and the attacks that we're going to talk about in this video. He'll tell us all about it, how he discovered it, and how to prevent these attacks. And before we jump in, please make sure you like the video and share it with friends to help us grow. And if you're interested in ethical hacking, cybersecurity, or bug bounty, then make sure you like the video, make sure you subscribe and hit the bell so you get notified every time we publish a new video like this one. Now, if you follow us on social media, you know I was at DEF CON 32 a couple of months ago, and I really enjoyed it. The venue was great, and there were so many amazing talks. One of these talks was by Vivek, in which he showed how to bypass enterprise-level security and get malware and phishing pages to be delivered, even if the target is using the latest and most advanced secure web gateways. But before we show you how to do that, let's talk about secure web gateways. What are they, and why would a company or an enterprise use it? Let's assume that we have a company in here with many employees, but as we know, many of the big companies these days have multiple offices. So they have their headquarters somewhere, and they might have other offices in different locations or even different countries. And also, as we know, a lot of companies these days allow their employees to work from home. As a result, they're going to have employees working from home, employees at smaller offices, and employees at a bigger or headquarters. And all of these employees need access to the internet. The only problem is, as we know, the internet is full of threats. It's full of hackers, it's full of viruses, it's full of malware, ransomware, you name it. And as a result, these viruses and malware would make its way to the company a lot of the time, even if the company is not being targeted, and again, potentially spreading throughout the company. Obviously, this would be a huge problem for organizations, and they would lose a lot of money and customer trust. And as a result, there are many security solutions to prevent this. One of which is what's known as secure web gateways. And as you can see, the idea is that you have some kind of a gateway that would stop all of these threats. So they can exist on the internet, they can go all the way to the gateway, but the gateway is going to stop all of these threats and making sure that the employees, whether they're working from an office or if they're working from home, are safe and secure. Secure web gateways do this by relying on malware detection, sandboxes, URL and file type filtering, firewalls, SSL inspection, and they might have many other features like data loss prevention and so on. As a result, ensuring that the employees, whether they're working from an office or from home, are secure, and as a result, protecting the whole company or organization. The only problem is secure web gateways are actually not that secure, as I'm going to show you. And as you can see, malware, phishing pages, phishing mail, viruses are making their ways to organizations, and as a result, organizations that are using the best secure web gateways out there, made by the best companies out there, are still getting hacked. But how is that happening? Well, first of all, secure web gateways only analyze the network traffic. Therefore, they are blind to many things, such as the web application itself, the user interaction with the application, the site permissions, the open tabs and windows on the client side, the extensions installed on the browser, and the many browser features and metrics that web browsers have these days. As a result, hackers are exploiting this in many ways. The first exploit is to send data through an unmonitored channel, somewhere that the secure web gateway is blind to. So instead of sending the malware through a channel that the secure web gateway is monitoring, hackers can send malware through another channel that the secure web gateway is completely blind to, and as a result, compromise the organization or the employees. And there are many examples of these channels that's not monitored by secure web gateways, such as WebRTC and WebTorrent, WebSocket, WebTransport, gRPC, and Firebase Cloud Messaging. All of these are protocols or methods of transferring data between 2 points, and you can look them up yourself. And all of these channels are unmonitored by secure web gateways, and therefore hackers can simply send their malware through it. The other exploit that I'm actually going to show you an implementation of in a minute is by sending the malware in an unusable form. So you can send the malware in chunks or hidden in an image or in a HTML page or in a CSS and so on. And a virus or a backdoor or an executable sent in any of these forms is unusable. It's actually not a threat. Therefore, the secure web gateway looks at it as if it's not a threat, because even if you put malware in a HTML page or in an image, that image is still going to be an image. It's not going to harm the computer. But you could then construct the malware at the browser, so at the client side. So you embed your executable in HTML, for example. The secure web gateway thinks that's completely fine because it's simply a HTML page. Even if it has an executable malware, it's not going to affect the computer. And then at the browser side, you extract that data, convert it to an executable, and have it downloaded as an actual executable that will be normally executed at the target computer and carry out whatever actions you want. So the easier example is actually simply sending the malware as chunks, as you can see in here. So assuming this is a virus, you send half of the code of the virus or multiple chunks in reality. The secure web gateway is going to think that this is not malware because, again, it's not actually full code. It's simply a fragment of a malware. It's going to arrive at the target, and then you send the other fragment. And then at the target on the client side, you combine all of the fragments into one usable malware and infect the target computer. Now, even though I've only mentioned 2 exploits to achieve this, there are many ways to implement these 2 exploits, and you can see all of them in here at browser.security. This is a website made by SquareX, the guys that discovered the attacks that I just spoke about, the last mile reassembly attacks. And this page is basically designed to highlight the different ways that this attack can be exploited and the dangers of this attack. So if you actually have an SWG or a secure web gateway, you can actually test it and see if it's able to block any of the malware that is included in this page. So as you can see, first of all, in here you have the attacks that should be detected by secure web gateways, and everything else that we have in here is not detected by secure web gateways. So as you can see, we have the unmonitored channels. So these are the channels that I spoke about in exploit 1 that you can simply deliver the malware through, and secure web gateways are simply not going to see it because they don't monitor these channels. Everything else you see in here falls under the second exploit, where the malware is delivered in an unusable form and then constructed at the browser. So a very simple example would be to send it in chunks, as I showed you earlier in the presentation. You could also hide the file in plain sight. For example, you can send the file using the WASM protocol or inside an image and then extract it out of the image inside the HTML page, inside a JavaScript, a CSS, an SVG, and so on. You could encrypt the file, but this is not the type of encryption that I show when we try to bypass antivirus programs. This is an encryption that makes the file unusable. And then when it's downloaded, you decrypt it. Same with the encoding. And then we will also talk about the phishing attacks in a minute, and I'll show you how to do that step by step. But before I show you this, I highly recommend you spend some time learning from all of the other examples. It's impossible for me to cover them all. And the best way to learn from these examples is to analyze the requests that happen between your browser and the web application. So to do that, first of all, we're going to right click and open our inspector. We're going to go to the network, and then let's go ahead and try an attack that we want to learn about. So let's assume we want to learn about the HTML embedded attack, where the malware binary is converted to an HTML element and then constructed at the client side. So we're simply going to click that, and as you can see, it's explaining to you how the attack works. And note, as soon as I click try attack, you're going to see the requests sent in here. So I'm going to click try attack, and you're going to see all of the communications happening between my browser and the application. And as you can see, the file got downloaded in here. the download was identical to any other download. It doesn't seem like the file was embedded in a HTML page, while in fact it was. And we can learn how that page was made by simply looking at the default HTML page. This is the last request we got. And if we right click it and copy the response, and I just want to show you what it looks like. So I'm just going to go to a text editor and we're going to paste it here. And it looks like it's gibberish, but many of you might already notice that this is base 64 encoding. And even if you don't know, if you scroll all the way up and you look in here, you'll see that it's telling you that this is base 64. So to learn how this works, I'm just going to remove the start of this, and then I'm going to select all of it, and then we're just going to decode it. So you can go to any base 64 decoder. I prefer this one right here. I'm going to paste all of the code that I have, and I'm going to click decode. And perfect. As you can see, once it's decoded, you should be able to see that this is simply a HTML element. It's a div element, and it's set to display none so that it's not displayed. And then the content of it is simply an array that represents the actual malware. But this array as is unusable. But because it's unusable, it's bypassing the secure web gateway, and once it arrives at the browser level, JavaScript is used to construct this array into an actual executable and allowing me to download it, as you can see, as a normal file. But what I really want to show you step by step is how to create phishing pages based on the phishing examples in here, specifically on the Canvas engine, that will bypass secure web gateways and bypass enterprise level security. And as a result, the phishing pages created using this method will not be detected by these security solutions. If you've been watching my videos and courses, then you know I cover multiple ways to create phishing pages. And these pages will work against most targets, except if the target is using an enterprise security solution, such as secure web gateways. But the technique that we just spoke about and that I'm about to show you will bypass all secure web gateways as of the date of recording this video, and even the ones that's included in the Gartner Magic Quadrant for SASE and SSE. These are the biggest public cybersecurity companies, and I'm going to show you how to bypass their secure web gateways next, step by step. See, traditional phishing pages are replicas or clones of original login pages, such as this one right here. So if we analyze the code by simply right click and inspect, you're going to see the HTML code responsible for rendering the element that we selected. As you can see, when I have my mouse in here, it's highlighting the input box in there. And then if we look at the code for the password, you'll see we have another input box that has a password, and all of this is enclosed in a form tag, a HTML form tag, which will submit the results to a certain endpoint. So this pattern is a pattern that's followed by many login authentication pages, and there's a few of these patterns, but secure web gateways are able to analyze this and detect phishing pages based on this HTML code that is usually used in authentication or login pages. However, the technique that is being proposed in here, as we said earlier, is to deliver our malware or phishing pages in a seemingly unusable form. For example, one of the examples here uses the Canvas engine, and if we click it, it'll actually explain to you how this is going to work. So as you can see, with this technique, instead of using code for inputs and login buttons, in this case, we're actually drawing all of the elements using the HTML Canvas tag or a Canvas engine. As a result, if we select the LinkedIn page here and open it, you'll see, first of all, it's identical to the normal login page for LinkedIn that we have in here. But if you look at any of the inputs, so if I inspect the element, you'll see it's not an input box as we saw earlier, it's a canvas. Same for the password. If we look at it, it's a canvas, and everything is enclosed inside a canvas tag, which basically means that this whole web page has been drawn on the screen. It doesn't use normal HTML elements that normal web pages use, even though it looks like an identical one. Instead, it's being completely drawn on the screen, and to make it functional, JavaScript is used so that when you click at this input box, it actually allows you to type in here in an input box. When you click here again, it allows you to type in here. And when you click the sign in, it's not an actual button. There is JavaScript that detects this click and then displays the information that you signed in with. Now, obviously, this code can be modified so that it stores this data or send it to you, whatever you want to do. But the idea is you can think of all of this as an image, and JavaScript is simply used to make this image functional. And therefore, as a result, when a secure web gateway look at this, it's gonna allow it, because to it, it's simply a drawing on a HTML page that cannot be used to do anything harmful. Now, you might think that this is pretty cool, but recreating a login page like this one requires deep understanding of the Canvas engine and JavaScript, and as a result, it is really hard. You would be right in thinking that, but we have AI now, and we can actually ask it to do this for us with a simple prompt. Let me show you how. So first of all, we're gonna go to the login page that we want to clone, and in this example, we're doing the LinkedIn page, so we're simply going to linkedin.com login, and I'm actually just gonna take a screenshot of this page. I'm going to take a nice screenshot that covers the whole page. And we're going to go to ChatGPT to get it to use the HTML Canvas engine to create a clone of the LinkedIn login page. Now, I've already written the prompt that I would use for this, so I'm just going to walk you through it. So we're going to attach the screenshot that we just took. So I have it right here. And we're basically telling it to create an interactive version of this using the Canvas tag. Make sure you put the two input box and the button. Now we're going to give it more information because it is very important to be very specific with the prompts that you give to AI. And I have a full course on that. If you want to check it out in the masterclass, I've been covering how to use AI for hacking for a while. Writing the right prompt makes a huge difference. So it's important to tell it that the users should be able to use the input boxes where there is input boxes on the screenshot, because it's simply just a screenshot. And when they click the button, it should trigger an action. And like I said, you can tell it to make that action whatever you want. For example, storing the information, but in our case, we're just going to say we want to display an alert message with the enter text so that it shows us the username and the password. Now, again, it's very important. We're telling it to use the attached image as a background in the canvas so that the screenshot that we just took in here will be the background. And then it's going to add code to make these input boxes and the sign in button function like actual input boxes and a sign in button. We're saying the interface should be drawn dynamically, again, highlighting the way that the interface should be usable, and that the interactions should be handled using JavaScript without using any HTML form elements, because we know these elements might be detected by secure web gateways. So obviously, this took me a few trials and errors until I got the right prompt, but make sure you include as many information as possible when using stuff like this. And as you can see, we are getting usable code in here. If you have the paid version of ChatGPT, you can actually use the Canvas feature where you can tell it to modify certain parts of the code if they don't work as expected. But we're not going to be doing that. We're going to stick with the normal ChatGPT-O. And perfect. It finished generating the code for us and it's telling us how to use it. We don't really care about how to use it. We're going to copy the code. And I'm going to go to my text editor. We're going to paste it and save it. And let's save it in my downloads. And let's call it linkedin.html. And if you just scroll up, you'll see that it's using an image source, very simple, and it's actually commenting it to you that you should put the uploaded image or the screenshot that we just took. So I'm actually just going to remove this. This is incorrect, but that is the correct name of my screenshot. So I'm just going to move it to the same working directory. I have my screenshot in my desktop and it's right here. We're going to copy it, go to my downloads, paste it here. Let's go ahead and run the code. And perfect. As you can see, it looks like the page works, but as you can see, the input boxes, and this is similar to what I got when I experimented with it myself before this video, the input boxes and the sign-in button are not aligned in the correct location. You need the input box to be placed exactly on top of this image. This second input box should be placed exactly here. And you actually don't need this sign in button to say sign in. It needs to be transparent. It simply needs to catch the action so that when you type something in here, it displays it for you on screen. So we're going to adjust the location of these elements so that they're displayed in here in their correct location. And then we will give that code to the AI and get it to clean it up and make sure that it's functioning as we want it. Now, you could ask the AI to adjust the location, but based on my experience, it will not get it right. Just not yet, at least. But if we scroll down in the code in here, as you can see, it's telling us the location of each of these elements. So we know that this is the input box for the email, this is the password, and this is the sign in button, because this comment is telling us these things. So the first thing is that we need to understand this part of the code. And if you've done any coding at all, this looks like coordinates to you. And usually the convention is this is the X coordinate, the Y coordinate, the width, and the height. So if we change this value, the X coordinate where this element is being displayed will be changed. And this is correct because as you can see, all of the elements, the email, the password, and the input button have the same X coordinate, which means that they are displayed at the same vertical coordinate in here. So if I adjust that, that'll adjust the three of them. And just to show you a proof of concept, if I select them all and change that to 500, save the page and refresh, you'll see everything moved a little bit from 330 to 500. So you're just gonna have to do a trial and error to make sure you align all of these inputs with the right location. Like I said, keep in mind, this is X, Y, width, and height. Now I've done the trial and error myself and managed to figure out the correct location. So I'm not gonna waste your time doing that in this video. I'm simply gonna paste it. I'm gonna save it, and you'll see if I come here and refresh, my inputs are moved and the sign in button is moved. The thing is though, if I click at any of these inputs, you can see that I'm not able to log in or input the password or the username. The reason for this is because the JavaScript that is checking if any of these drawings are being selected is checking for the original coordinates that we had in here. Therefore, to adjust this, you can come here to find out the JavaScript responsible for detecting the clicks, as you can see in here, and it checks if the X is greater or smaller. So there's a bit of calculation involved in this. And because we're lazy, we're actually just going to copy all of this, go to the AI and get it to do it for us. So we're simply going to give it the code. And at the top, I have a prompt that I've already written, but it's very simple. All we're going to say is I've manually adjusted the input boxes and button to appear in the right location. Please adjust the rest of the code to work with the new location of the boxes. We're going to hit enter. It'll read this and it'll adjust the JavaScript portion of the code so that it detects the right locations where I'm selecting the input boxes. We're going to give it a minute to generate the output. And now that it's done, we're going to copy the code. We're going to paste it in here, save it, go back to our page, refresh. It looks the same, but hopefully this time it's going to work. So I'm going to click here. I'm going to type some text in my keyboard. And if you can see, the text is being typed, but it's in white. We're going to get it to fix that again, but it looks like it's able to detect what we're inputting in the right location. And if I click sign in, perfect. As you can see, it's able to detect the username and the password. Now again, this page doesn't look great. We've got white text in here and we've got double borders in here. And also the sign in button looks weird because the original sign in button had curved edges. So let's go ahead and fix these issues. We're going to focus at one issue at a time. So I have a prompt that I've already designed for this, but the result I got earlier wasn't identical to this. So I'm going to have to slightly modify my prompt. So we're going to say once an input box is clicked, set the background color to white and keep it white even when it's out of focus. Before that, I'm going to tell it, perfect, set the text color in the input box to black. And we're also going to tell it, remove the borders around the input boxes. And then we're telling it once the input box is clicked, Set the background color to white so that you don't see the label in here that is saying email or phone, and keep it white even when it's out of focus. That's how specific you have to be. When I tried before, it did what I asked it to, but then when the element went out of focus, it brought back the label that was saying email and password in here. And now that it's done, we're gonna copy the code, paste it here, save it, and let's test it. And perfect, as you can see, now we don't have borders on the input boxes. Let's see if we click it. As you can see, that's perfect. The text, the label text is gone. And if I type anything, it's being displayed in black. Same if we type anything in here, you can see we have a little display issue in here, but that's fine. You can go to the AI and ask it. I'm not gonna waste time on that issue. I'm gonna click on sign in. And again, as you can see, we have the username and the password. So let's give it a refresh. And the last thing that I want to do is hide this sign in button, because like I said, we want to see the curved sign in button. Keep in mind, we don't actually need to see the sign in button because we already have an action that when you click on this part of the image, it's going to execute the rest of the JavaScript code that is displaying the username and the password for us. So all I have to do is go back to the code in here and simply remove the sign in button altogether, because the action is being captured in the JavaScript in here. So we're gonna save it and let's go to our page, refresh, and perfect. Look at this page. It looks identical to the actual login page of LinkedIn, but it does not use any proper HTML elements. Everything in here is drawn. First of all, we have a screenshot that is the background of this image, and we've got JavaScript that is making the input boxes in here behave like input boxes, even though that they're not. And then when we type information in here and hit sign in, we can execute any code that we want, but in this case, we're simply getting it to be displayed on screen. And this technique will bypass enterprise level secure web gateways that cost millions of dollars every year and promise to prevent these kind of attacks. Now, like I said, you're in for a treat because I have the guy that discovered all of these attacks along with the famous Cafe Latte attack here on Zoom to explain to us how he discovered all of these attacks, what does this mean for enterprises, and where do we go from here to prevent these attacks. Thanks for coming for this call, Vivek. It's an honor to have you. I actually was there at the talk in DEF CON, but I didn't come in and say hi. I should have actually done that. But hopefully in future ones, we should actually go in for a coffee or something.
Yeah, thanks so much for inviting me on the show. The pleasure is mine. And absolutely, next time we are ever at a conference together, definitely hit me up. Would love to grab a coffee and talk InfoSec.
Yeah, would love to. Would love to. Now, I've showed off a demo of one of the ways to implement the 0 mile attack. Obviously, there's many ways to exploit this.
Yeah.
And as people are seeing in this video, it's pretty easy to do. It doesn't take that much time. And obviously, if you put more time into it, you can make it even more sophisticated and bypass even
Yeah.
potential updates that secure web gateways will push in the future. So,
Yeah.
do you agree on that? What's your take on it?
Yeah, absolutely. And interestingly, what's been happening is when we are speaking to a lot of large customers, just like what I mentioned, many of these secure web gateways are now shooting the messenger, which is when customers point out to them that we are able to see bypasses on browser.security. Many of them have started blocking browser.security as a site rather than go fix the attacks.
Mm-hmm, mm-hmm.
So absolutely.
That's actually pretty deceiving, isn't it? Because they're not really fixing anything. They're only blocking your domain. I can obviously, if I create my own domain when I'm exploiting it, I will bypass it.
Correct. So I think what most of these vendors are hinging on is, an average customer isn't going to be contacting SquareX and saying, oh, your site seems to be blocked. Could you spin up a new one so that we can do a test? So, that wouldn't happen. And that's really where they hope that probably they can get away, at least with some customers. So what we've started doing is we have a special internal tool. So
Mm-hmm,
when we talk to a prospective customer who says, oh, you know what, browser.security is blocked, we
mm-hmm,
just spin up a new instance in a random domain
mm-hmm.
and then give
And it
them
works again.
access.
Mm-hmm.
Yeah, and which makes it even more potent because now they go back to the vendor and say, look, you're clearly fooling us.
Yeah, yeah, that's very deceiving, especially for these contracts, which, as far as I know, are very, very expensive.
Yes, I think an average SASE SSC contract for a few thousand employees can actually run into millions of dollars
Yeah, that's crazy.
a year.
That's crazy. Yeah, I mean, if you get your value, that's fine. But the problem is you're not getting the value that you're expecting.
Yeah.
And tell me this: how do you go about? Because I'm sure our audience is asking, how do you go about discovering such exploits? Because a lot of the time people think, oh, secure, like an enterprise solution is being used or SWG is being used, and automatically in their brain,
Yeah.
the target is very secure. It's unbreakable. So, what's the kind of mentality you have? And if you can just tell us quickly how you get into exploiting such systems.
Yeah. Actually, that's a great question. So, all my career, I've been exploiting, open systems, finding vulnerabilities in Wi-Fi, like Cafe Latte and all of that.
Mm-hmm.
And to your point, most security researchers do that because, the documentation is open, the software is available. Incredibly, when I started building enterprise security software and started looking at it, I figured that there were a lot less researchers
Mm-hmm.
trying to target and pen test enterprise security products because it's so difficult to get access to them anyway.
Yes.
And I feel that has become a very big barrier to entry at this point in time. And this is really where what I would even recommend is, I mean, some of these companies do have their, vulnerability research programs. In other cases, of course, you could try to talk to companies in your network who are deploying them
Mm-hmm.
and then just offer up like a free pen test. Like just
Mm-hmm.
go in and say, hey, I just do this for free. I just want to see if, somebody can bypass it. Uh, and if it does, you get to know what vulnerabilities are there. And if not, you can feel more secure in your investment.
Yeah.
Uh, if at all there's one key takeaway is the fact that go try breaking enterprise security software. It is more vulnerable than you can imagine. I actually feel like the open source standards and others are a lot more secure in comparison.
Mm-hmm. I couldn't agree more because with open source you can see the code, and as a result, it's it
Yeah,
is easier and it's more evident, and the developers know that people are going to be reading the code and potentially finding vulnerabilities. So it's basically what you're getting. Well, not always, but you could be getting security by obscurity just because people aren't testing it, but it's not really secure.
exactly. Exactly. You brought up a great point. And to your point, what also tends to happen is, see, most people's security journeys begin with tool like Nmap and Metasploit.
Mm-hmm.
And when you start setting up targets for Metasploit, generally this would end up being open source, free software, and things like that.
Mm-hmm.
So a lot of folks doing this, including bug bounties, tend to gravitate there. And you're right, like much of enterprise security in my mind is security through obscurity. There is very little documentation. Most of these enterprises are not open and discussing about how the security products are working. And that's really where a black box approach is the one that you have to take.
Yeah, that's kind of unfortunate. But what about, so based on everything that I've shown in this video, and you obviously demonstrated at the start, um, what about enterprise browsers? Would they stop these attacks? Because I feel like people are in the comments right away are going to say, well, that's a good solution for it. So what do you say to that?
Yeah, so I think the way I look at browser security is enterprise browsers at this point in time are these monolithic browsers which are built off Chromium.
Mm-hmm.
And a lot of companies go ahead and add their own features and they're shipping it to customer sites. The
Mm-hmm.
main use case that enterprise browsers solve today is access control to private apps sitting in the customer's data center, whether on AWS, GCP, or even private data centers.
Mm-hmm.
So I think all of them, I mean, and this is the bad thing in cybersecurity is everybody does the whole marketing gimmick by having a 10 sub bullet checkpoint of things that they do. Almost all enterprise browsers mention that they also do, attack detection, threat detection.
Mm-hmm.
But most of them just rely on Chrome's basic threat detection to go about like serving that. So
Okay.
what we found is when we've talked to a lot of people who've deployed enterprise browsers directly, the fact that attack detection, threat detection is not something even the vendors show off, during customer calls and things like that.
Mm-hmm.
Uh, and that's really where I think the need is really for browser native security products whose sole focus is actually to detect attacks and to block it, rather than a multi-purpose solution where attack detection is just a bullet point.
It's just a bullet point, and it's just using the default feature that you get with normal built-in browsers. Interesting.
Right.
So basically, you could test how good these are by using the actual browser, and these are bypassing a lot of it anyway.
Exactly, exactly. So, I mean, you brought up a good point. The problem is most people, again, not having access to these products, we end up looking at just the marketing material and saying, oh, you know what,
Hmm.
it protects against everything.
Yeah, yeah.
Right? It's the same way as antiviruses, we protect against ransomware. We all know how easy it is to bypass traditional AVs.
Mm-hmm. Yeah, interesting, interesting. So if the enterprise browsers are not the solution, or secure web gateways aren't the solution, what would you recommend beside education? Because you can always say educate your employees; they should be able to detect these kind of stuff. But if we wanted to deploy something in a big organization or a big company to
Yeah,
prevent
yeah.
these kind of attacks, what would you recommend?
Yeah, yeah. So, I mean, without making it, more about SquareX, I'll just talk about in a generic term.
Mm-hmm.
I think what I realized, and given the fact that before this I used to run Pen Tester Academy, we had like red teams from literally, I think, over 100 plus countries, all big banks, financial institutions talk to us.
Mm-hmm.
And that's really where what we realized is, most organizations don't even understand how to instrument web attacks happening in the browser because there's no visibility.
Mm-hmm.
Now, at the same time, what tends to happen is most employees love to use multiple browsers, right? All of us have Chrome,
Sure.
Firefox, Safari.
Yeah.
I personally use like Safari for social media, Chrome for everything else, and Firefox for all my, banking transactions.
Perfect. Now I know how to target you.
Yeah. So that is really where a solution is required, which can work with all browsers.
Mhm,
Now, the tricky part is, of course, Google or, none of the browser vendors are just going to open up for any company to integrate. So
mhm,
the only way that you can build an integration is via browser extensions. Now, the moment people hear browser extensions, the first thing comes is, could a browser extension even do something like this?
mhm.
And that's really where it's important to understand that browser extensions are actually working at a privilege level above web pages, tabs, and windows.
Okay.
And there are various APIs that browser vendors have made available to these extensions in order to be able to monitor things, hook into events, block various actions, and whatnot.
Mhm.
So you should think of browser extensions like Linux kernel modules, just a little bit less powerful for what it's worth.
Right. Okay.
Now, when you look at these browser extensions, the additional thing people generally tend to ask is, oh, the user could just go and disable it, and all the attacks now kind of like go through.
Mhm,
Well, just like if, when you deploy endpoint security, if you deploy a browser extension via a group policy or an endpoint security management solution,
mhm,
because these are managed devices, the users are unable to remove the extension because your browser becomes the managed browser.
mhm, mhm.
And unless they have local admin rights, they really can't do much, which is your,
Okay.
enterprise employees. So I think this is a very interesting, unique approach because second order, browser extensions can watch DOM events, can monitor everything which is happening, which basically means they could actually become a product residing in the browser itself, detecting and blocking attacks. And that is honestly the thesis at the DEF CON talk, which I mentioned,
Mhm.
is think about it, right? Any security product should have 100% visibility, right? 360-degree visibility.
Sure. Of
The
course.
second thing is the ability to block anything.
Mhm,
And browser extensions can actually do both. And that is really where they're that perfect combination to go build a security product on when it comes to client-side web attacks.
mhm, mhm. I like the idea of the way that it's sitting on the client side. So what it sees is what the client sees, whereas with secure web gateways, they don't actually see what the client sees. As we saw, we can send things in chunks, we can send things in obscure formats, and they'll go through. And then when they get to the browser, we can build them and make them look like something completely different, construct them into something completely different. But that's not going to happen with the extension, correct? Because it's able to
Exactly.
see the end result, the end malware or the end phishing page that I'm creating. It's able to see that as well.
Exactly, exactly. And the best way to kind of visualize is imagine that you're, inside a building and then you have security cameras inside.
Hmm.
And then outside the building, you have security cameras. So your secure web gateway is like the security camera outside the building, which is the browser. So
Mm-hmm.
all it can finally see is the end product of what is going in and out,
Mm-hmm.
versus security cameras in the building, in the browser, like a browser extension based security product, can look at every micro action which is happening, leading to finally the data getting sent out or being received.
Mm-hmm.
Uh, so, to your point, the only way is actually to view the web as a security product identically to how the user is viewing the web and interacting with the web.
Yeah, makes sense.
Uh,
Makes sense. Are there any? I know you said you don't want to make this into a pitch to SquareX, but I don't know. Is there any other products that do this? SquareX, you do have a product that does that, right?
yeah. That has been our focus from the beginning. So what we've kind of found is, many, as I mentioned, enterprise browser security companies, they try to put this on as a checkpoint.
Mm-hmm.
The key difference, what we've seen is given my whole background for the last 20 years has been from a red teaming attack perspective.
Mm-hmm.
I tried to build a product to defend, thinking always about the attacker.
Sure.
And I'll take like a step back and I'll tell you, now that I've been building this company, my thesis is in cybersecurity, there are really two kind of companies.
Mm-hmm.
One company gets built by people, and this is, I'm talking about product companies. One company gets built by people who worked in very large organizations, and they start to look at process issues in cybersecurity, right?
Mm-hmm.
Things like SOAR platforms, SIM platforms, and things like that, which is all about better management of security processes, streamlining data, and things like that, right?
Mm-hmm. Mm-hmm.
And the second kind of company is actually built primarily by ex-attackers, people who love breaking into systems because
Mm-hmm.
they have an outside in view.
Mm-hmm.
And they always try to figure out like how attackers would do this and what could be a possible defense.
Mm-hmm.
So I feel a lot of the companies in enterprise browsers have taken more of the former approach because they're trying to make security processes around accessing private apps more simplified and streamlined,
Mm-hmm.
while our entire focus has been, blocking web attacks. So the way I describe ourselves to potential investors and everybody is just the following. I say what EDR, XDR is to a computer, SquareX is a BDR or browser detection response to the browser.
Mm-hmm. Which is
Uh,
what everybody, like most employees and even users, the first thing they do when they launch their computer is the browser.
exactly,
We do everything
exactly.
through the browser these days.
Yeah, yeah. 90% of time is spent in the browser, 10% in applications like Outlook.
Mm-hmm.
And I always say, you have to look at the younger generation to kind of like figure out where trends are moving.
Mm-hmm.
And I haven't seen anybody in their 20s use Outlook. All of them use webmail.
Yes.
And
Yeah.
that shows in the next 7 to 10 years that it's going to be a web only world.
Yeah. You have even designers now using Canva and all that, and it's moving away from,
Exactly.
Photoshop and all that.
Photoshop.
So yeah, no, I fully agree with everything you said. The obviously how important it is to secure a browser and the approach where the extension is sitting there looking exactly at what's happening in the browser instead of something that is in the middle that's blind
Yeah,
to a lot of the other stuff that's being constructed later on at the client side.
exactly. Exactly. Absolutely. And I think what tends to also happen is, the way I've seen cybersecurity in the last 25 years
Mm-hmm.
is generally when a new class of attack is discovered, which existing security products architecturally are unable to solve.
Mm-hmm.
That is really when a new class of security product starts to emerge because there is really no option.
Mm-hmm.
Now, of course, there is a window of this kind of a window of opportunity and gap between a new attack getting discovered and attackers in the wild using this, for every single thing.
Mm-hmm.
And that is just the amount of time that larger companies have to build a product or startups like SquareX have to build and to capitalize. So, uh, some interesting things I've realized about the market in that way.
Yeah, yeah, it's interesting. Obviously, the attack is more achievable and more accessible because it's been published now, so people really need to
Yeah.
find a solution
Yeah.
very quickly.
Actually, you'd be surprised, right? And without taking names, I have literally spoken to every single large vendor out there.
Hmm.
And almost all of them, their security teams, when they look at it, they realize this is a problem and they can't solve it. but they will not put out an advisory to their customers till the time a large number of their customers don't start complaining.
Hmm. Yeah,
So,
I feel like this is a kind of a pattern as well, though, isn't it?
yeah, yeah. I mean, it is kind of like disappointing because you would kind of assume that security companies would be the first to respond.
Hmm.
Uh, but I think, it's a problem only when most of your customers think it's a problem. And that's what the larger companies, their thesis is when it comes to acknowledging problems in their products.
Yeah. A lot of the time, also, they want to tick a box, they want to meet regulations, they want to get insured, and
Correct.
what you're talking about isn't part of it. It's, if they get hacked or not, it doesn't matter too much as they have to tick the box to say that they implemented whatever it is in the Martyr, AT&T, or whatever standard they're trying to implement. They get to tick the box, they get to meet regulations, and they're happy. But I think raising awareness the way you are doing is a win-win, because first of all, they're raising awareness anyway against actual issues that people need to address, and at the same time, you do have an actual good solution out there. If they want it, they can come take it. If they don't, at least you raised awareness about this really bad issue that most companies have at the moment.
Correct, correct, correct. Absolutely. And to your point, that has been the way that I have embraced because that's all I know, right? Like, which is,
Yes, that's where you started from. Yeah.
yeah, and SquareX should only exist, or any browser native security product should only exist if genuinely there are architectural vulnerabilities in existing products that are unsolvable. Or
Hmm.
else they would just patch it. Like, we
Exactly.
don't
They
need
could
to
just, exactly. Yeah, exactly. I see what you mean. Well, thank you very much for coming. This has been very informative. I'm sure everybody here in the comments are gonna love it. Thank you very much. The way you
Thanks.
think about it, approaching these, it's very important, because a lot of the time, a lot of my students also just think an enterprise solution is bulletproof, and it's you just said it there yourself. It's actually more vulnerable than open source stuff that they're used to test, because less people test it because it's more expensive to buy. But once you see it, don't be disheartened or thinking, oh, this is a bulletproof solution. Try the same ideas that we have as pen testers, sending things in chunks or saying them in a different way, all these kind of things. And a lot of the time, as we saw, you manage to break it in so many different ways.
Yeah, yeah, absolutely. And to double click on that, I would highly recommend, your students or anyone watching this to go start pen testing security products rather than just open source ones, and you'll be surprised at the sheer number of vulnerabilities that you find.
Well, there you go, guys. You heard it from the man himself. Go pen test as many products as you can. Thank you very much for coming again.
Thanks.
And thank you very much, guys. I hope you enjoyed this video. Let us know in the comments if you have any questions, or if you want to discuss anything, we'd be happy to reply and help you out.